So this one is October, November 2017. The second part is related to the moles, and we'll do the moles part. Like we have 6 grams of copper 2 oxide and was added to 50 cm cube of 1 mole per dm cube hydrochloric acid. This was an excess of copper 2 oxide. Like we have more than enough copper 2 oxide. So how we'll know that copper 2 oxide is in excess when this reaction happens?
It totally dissolves.
No more decrease in size.
No more. No dissolving.
No more dissolving, or the solid will appear. Like no more solid dissolve, or the solid will appear, because like if you have excess of a solid, then the solid will appear. Then the next part, like the first part is related to about the collision theory and explain how temperature affect. But as we are doing the moles part only, we'll discuss the moles. Calculate the number of moles of copper 2 oxide which are added to hydrochloric acid. How to get the moles of copper 2 oxide which are added? So we have 6 grams.
N equals mass over molar mass.
So we have 6 grams. If we have mass in gram, what we will use? We will use a formula.
Mass over molar mass.
So we'll use a formula: moles equal mass in gram divided by the molar mass. Mass in gram is 6. What about the molar mass? So for molar mass, we have to check the periodic table. Copper 2 oxide, the formula of copper 2 oxide is CuO. So you have to check the periodic table. What is the mass of copper in the periodic table?
64.
So mass of a copper is there, that is 64. And what is the mass of oxygen?
It is 80.
60 oxygen.
16.
16.
Total.
Yeah, okay, you are talking about total. I thought you were saying about oxygen. Yeah, so this will be 64 plus 16, that's equal to 80. So 6 divided by moles equal mass in gram over molar mass. So we will do 6 divided by 80. What's the answer?
So Mr. 0.075.
So we have 0.075. These are the moles of copper oxide. That's the first thing we did. The next, calculate the number of moles of hydrochloric acid used. So
here we have to use the concentration into volume.
Yeah. Why we use concentration into volume? Why we did not use a ratio? Because if you see the question that about the hydrochloric acid, we have both things. We have the volume and we have the concentration. So we have concentration and volume. That's why we did not take the ratio. If nothing was given or incomplete information is there, that time that's why we'll use a formula if we have volume and concentration. If nothing was there, we will use a ratio. So it is 50 cm cube and 1 mole per dm cube.
So Mr. It will be 50 divided by 1000 multiply 1 equal 0.05.
Right. So concentration into volume, but volume should be in decimeter cube. Concentration is 1, but the volume is 50. We divided by 1000 to convert into decimeter cube. Why we did not take a ratio here? The main reason is because copper carbonate is in excess. If I take a ratio between copper carbonate and the hydrochloric acid, it won't be correct. Why it won't be correct? Because that will give us greater amount of hydrochloric acid. Because these are the total moles of copper oxide, but not all of them reacted. As we know, the copper oxide is in excess. So if I take a ratio, you will get the wrong answer. The answer won't be same, because that will give us extra quantity of hydrochloric acid. Not all 0.075 moles of copper carbonate reacted. So moles is concentration into volume. What's the answer for this? So 0.05.
5.
The next part, calculate the mass of a copper oxide that did not react.
Here we will divide 0.05 by 2 to get which got reacted and find the mass in grams from it.
But we need the mass which does not react. So these are the total moles.
We will minus it.
Minus, yeah.
From 6.
Look, These are, yeah, I will explain that part. Look, these are the total moles of copper oxide. That is what we have in the experiment. These are the moles of HCl. Now, first what we'll do, we'll use a ratio to get the moles of copper oxide which will react. And then we will subtract, like from total moles, we'll subtract how many reacted, so we'll know how many did not react. And then multiply by molar mass to get the mass in gram. So we'll take a ratio between copper oxide and hydrochloric acid. This is to find how many moles of copper oxide reacted. So what is the ratio between them according to equation? When
1:2.
1:2 is the ratio that is given in the equation, like the beginning of the question, there is an equation that shows that the ratio is 1:2. So ratio is 1:2. So using the ratio as it is 1:2, we have 0.05 moles of hydrochloric acid. We are finding how many moles of copper oxide are there. We cross multiply.
0.02.
So we'll find 0.025 moles of copper oxide which will react. But the question is not how much reacted. The question is what mass of copper oxide did not react. So how we know how much of copper oxide does not react, or moles of copper oxide which does not react? So total moles were 0.075 and the moles which reacted were 0.025. So how many moles of copper oxide does not react? So when we subtract,
0.05.
So 0.05 moles of copper oxide which does not react. And now we need the mass in gram. Like the question is what mass of copper oxide? Yeah. What mass of copper oxide does not react? So you have the formula moles equal mass in gram divided by molar mass. So moles which does not react were 0.05, mass in gram we don't know. And the molar mass of a copper oxide we already did in the first part, that was 80. So we multiply 80 into 0.05. 4. So it means 4 gram of copper oxide, 4 grams does not react. This is one way. Like we got the moles and then we did. There's also another way to do this. Like first you will find, because we know the total mass, like this is one way of solving. The other way of solving, the third part, if I want to, I will find how many moles of copper oxide reacted. So I work out ratio 1:2 and I got the moles of copper oxide which will react, that is 0.025. Then I will find what mass of a copper oxide will react. So I will use moles 0.025 equal mass in gram divided by molar mass. This will be multiplied. So 0.025 times 80. What's the answer? 0.025 multiplied by 80. How much mass is reacted? 2. So means 2 grams is reacted. So in the beginning, we were having, as you see the question, the beginning of the question, we were having 6 gram of copper oxide. And out of 6 gram of copper oxide, 2 grams is reacted. How much unreacted? 6 minus 2, that's equal to 4. So you will get the same answer. So you got the moles, then at the last convert, or you first get the mass and then subtract, it will give the same result. Is it clear?